Hello everyone, welcome to AI Anytime channel. In this video, we are going to explore a lightweight library named Unsloth. So Unsloth is a very recent library that helps you fine-tune large language models. So it helps you speed up your LLM fine-tuning process with also less memory consumption. They said 4x to 5x speed up and 60% less memory. That's what the tagline on GitHub. Now, Unsloth is powerful. And that's because I have used Unsloth in some of the fine-tuning experimentation and it really performs well. And today I will show you in this video that how you can, work with Unsloth for a fine-tuning task in a Colab notebook. Now, Unsloth supports different types of fine-tuning techniques. Like with SFTTrainer, you can also use TRL, Transformer Reinforcement Learning, and we'll do Unsloth plus TRL combination in this video. Now you can use SFTTrainer, PPOTrainer, DPOTrainer, and whatnot. Okay, and it supports all the almost all the NVIDIA libraries that supports CUDA kernels, and also like the newest one and the older one. For example, in the talk about the newest one, it supports your RTX 3090 and the similar GPUs. It also supports A100, V100, T4, and so on and so forth when it comes to GPU. Now, the good thing about Unsloth is that they have worked really well on the optimization techniques. Okay, and that's the underlying concepts of Unsloth, reducing the memory consumptions and the requirements and increasing up or the speeding up your fine-tuning process. They basically rewrite all the PyTorch modules to Triton kernels, and that's the one of the reason that the framework is extremely powerful that helps you optimize. Now they also derive the back propagation steps manually. That's also a feature of Unsloth, and we'll cover these two or three features in details. They also say that there is 0% loss in accuracy when it compare that to regular QLoRA method that we have seen. So these are some of the features that Unsloth provides, and you can combine Unsloth with different libraries as well. So we'll see how we're going to use TRL. We'll use SFTTrainer through TRL and combine that with Unsloth library to fine tune on IMDb dataset. So we'll take a text generation task here. We'll see if it's able to generate some text and how fast we can use Unsloth to fine tune this and inference as well. And we can also push that to Hugging Face. I will also show you that how you can push it. And the notebook is available on my GitHub. If you don't want to watch the video, you can just go on and look at the notebook. But I will recommend that you watch the video to understand that a few things when I while I'm coding. Now, without further delay, let's jump into Google Colab Notebook and see how we can use Mistral and the Llama's model, any one of these two, because these are the supported model, and we can, start our journey with Unsloth for fine-tuning tasks. All right, so we're going to experiment Unsloth in Google Colab. I'm going to use the T4 GPU that you can see. I have Google Colab Pro, but I'm not using the A100 or the V100, but I'm going to rely on T4 GPU. Now, currently, Unsloth supports Llama and Mistral architectures and different types of architectures within these two, different types of model and the variants within these two architectures. For example, Tiny Llama, Code Llama, DeepSeek. If you talk about some Japanese like QN, Lamified QN, etc. Now, if you come to their GitHub repository, both Unsloth and TRL, trained transformer language with reinforcement learning. Now, Unsloth has more than 60 collab notebooks or like notebooks where you can reproduce all the examples and different techniques like PPO, DPO, and so on and so forth. Now they have the evaluation benchmarks, which is defined over here, and they have all the installation documentations and some examples. But let's see how we can experiment here in Google Colab, and we'll see are we able to do it on T4 GPU or not. So uh, if you are using T4, I have the installation. I'll give that link in description that how you can install, because A100 will take a bit of different route for installation. A100 and both B100 GPUs, or even the newer generation RTX GPUs have their own way of installing Unsloth. Now, let's wait for it. It will take a bit of time to install, build, and all. And I'm gonna get transformers, and then after that, also we need TRL. So let me just add. pip install TRL thingy, pip install TRL. Okay, now this is the TRL repository on GitHub. This transformer reinforcement learning, and they support SFT reward, pro trainer, PPO trainer, and similar techniques to fine tune or train pre-trained large language models or language models. Now, when it comes to Unsloth, they say that you know 4x faster or 5x faster model downloads reduces the memory fragmentation, which is a big problem when it comes to AI models by about 500 MB and can fit larger batches as well. So it's very helpful. Like that helps you load the pre-quantified 4-bit models, and they provide some pre-quantitative models like uh, Llama 27B 4-bit, 13B 4-bit, Mistral 7B, and Code Llama 34-bit. So they supports all these models right now. These are all quantified model. Now, Unsloth also performs rope scaling internally, so larger maximum sequence lengths are automatically supported. Automatically, it supports a large max sequence length. That's very helpful. Now, uh, to work with it, that how you're gonna load this. So there's a class, but let me first show you, and then we'll go into the TRL and stuff. Let me first so from Unsloth import, and they have a class called fast language model. So you have to import that fast language model thingy. Now this is how you import from Unsloth import fast language model. And earlier we used to, once you use transformers, you used to get it from causal LM from pre-train and stuff. Right now, in this case, what you do, you get it in model tokenizer equals, and you get it from fast language model. So you have to do fast language model. This is wrong. Then we say from pre-trained. Okay, so something like this, right? But not GPT-2. And then you can use the model name, max sequence length, loading 4-bit, and all those parameters. As it supports rope, you can choose any max sequence length. Okay, it automatically supports. Okay, now once the model is loaded, we can use again fast language model class to use the get pipped model to that module to attach the adapter and perform QLoRA tuning. I'll show that in a bit. Let's have a look at the uh, TRL integration with Unsloth. So to use Unsloth with TRL, you simply pass the Unsloth model to SFTTrainer. Or even if you want to use DPOTrainer, you have DPO setup ready with you, datasets, reward, etc. You can also get it done. Now, the trained model is fully compatible with the HuggingFace ecosystem. So once you train it, you will be able to utilize it through HuggingFace as well. So let's try it out, on uh, in very brief here. So I'm going to have import torch from TRL. I'm gonna get import SFT trainer here, SFT trainer, and then from transformers import, and I'm gonna have training arguments. So training arguments, and then I'm gonna have from Unsloth. We already have fast language models, we don't need it. Now our imports are done. Okay, we have to get data sets also. So let's get the data sets over thing here. So from data sets, import load data sets. You're gonna use a Hugging Face data set. You can use your data set as well, it's fine. Fine. Now we are okay with our imports. Let's define a max sequence length. So I'm gonna have max sequence length equals 2048, for example. I'm keeping it on higher side. Now let's get the data sets. I'm gonna write data set equals and load underscore data sets. And if you come here, you just do IMDb Hugging Face. Okay, now once you click at that, you will see an IMDb dataset that Hugging Face provides. And let's use that datasets. Okay, on Hugging, which you can see that's the dataset we're gonna use. Now, so let's just write IMDb, and then you give split equals train. It's getting it now. Once you just put the dataset, it will give you uh, to once you do dataset, it will show you the features, text and label, and number of 25,000 rows. If you come here, you can see train 25k rows. Two classes. It's a text classification, sentiment classification dataset. So if you want to use This data set you can fine tune for sentiment analytics on some kind of products or movie reviews and so on and so forth using Unsloth, which is really fast, helps you do faster inference. Now, here, let's get the model tokenizer thingy. So model tokenizer equals, I'm going to use fast language, and you can see this is what it's showing me. This is correct. But here I'm going to write model name. So let's use Mistral by Unsloth. So Unsloth provides, let me just write Unsloth, and they provide a Mistral. So if you come here, Unsloth, Mistral, HF, once you write it, it will take you to here and you'll get it. They have all the models available that you can utilize. Okay, if you come down, I'll show you. You can see these are the 4-bit model that they provide. So let's use the 4-bit quantized model. Okay, and say 4x faster downloading that they support. So let's see that if that's possible. So Mistral, and I'm gonna say 7B, and this is how you define BNB, bits and bytes, and then it goes 4-bit. It supports llamas also. You can also get it with llama as well if you want. Then max sequence length equals to max sequence length, and then you have d type. So let's keep it none. Make sure you keep d type none here, and then you keep load in 4-bit true. So load in 4-bit, and that also automatically helps you fine tune with QLoRA. Load in 4-bit equals true. Fine. Now we are okay with this. Load in 4-bit. Okay, true. Now let's just run this and see. It says you passed quantization config to from pre-trained, but the model you are loading already has a quantization config attribute. Okay, you can see the Unsloth fast fast Mistral patching release GPU Tesla T4. It gives you a verbose description about the configuration that you are currently using of your hardware, CUDA capabilities, blah blah blah, and it's getting it. You can see it's downloads. Let's see the model thingy now. Okay, and you can see the model has been downloaded. The model saved tensors and the entire thing. It's extremely fast. That's fantastic. Now let's use PEFT, get PEFT model module from it, fast language model, and that helps you do the model patching and add fast LoRa weight. So for that, I'm going to do model equals fast language model dot not from pre-train. Now I'm going to use get PEFT. So let's just do that. Get PEFT model, and then you have model, and then let's keep the rank. If you are using a very small model, your rank should be higher. I have a very detailed video on these topics. Please watch that. I'll give the link in description. Let's keep the target modules. So for this model, that's what they suggest on the documentation. And I have explained this in my previous videos. What is Q projection? What is up projection? What is K projection? What is output projection? And so forth, so on and so forth, right? You can just have a look at those projections and target modules. What does it mean? K pros and V pros, and then goes your O, and what else we have gate projection. So let's keep gate projection, excuse me, gate projection. Then we have upward, so up proj, and then down proj. This looks good. This should do that. Okay, let's see, this should work. Now let's go have an alpha value for LoRa. So LoRa alpha, I'm not explaining each of these terminologies as I have explained earlier in my videos. LoRa alpha, and then you're gonna have LoRa dropout. So let's keep LoRa dropout. I'll keep it 0, but 0 is more optimized. It suggests 0.1 here, but you can keep any. It supports that, but 0 is the optimized one. LoRa dropout, then bias as none, and then let's keep the gradient checkpointing as true here. So use gradient checkpointing true, and then let's keep a random state, something high. So for example, let's give 3 4 not 7 or something like that, and max sequence length goes to max sequence length. I think this is fine. So this will do the model patching and also add the LoRa weights, fast LoRa weights by the way. And I hope this makes sense. So let's run it and see what happens here. So target modules, I hope target modules work. Q pros, K pros, V pros, O pros, get pros. This is what my notes shows me here. So I have in my notes and up pros and down pros. This should work. Let's see. It says Unsloth to, oh, it's patched 32 layers with 32 QKV layers. Oh, fantastic. 32 O layers and 32 MLP layers. Pretty fast. Okay. Now let's define a trainer. Supervised fine-tuning trainer. Let's do that. Train dataset equals dataset. Dataset text field equals. I want to keep this text because this is what my text is. If you look at here, this is the text that we have. So I'm just going to keep text here. So let's do that. Dataset text field. Then max sequence length, tokenizer, and then you're gonna have arguments. So let's keep arguments. So arguments, you're gonna use training arguments here. So training arguments, and inside training arguments, we're gonna have batch size. So per device batch size. Why it's not showing me? But hopefully this is how we do it. Batch size. Okay. Per device train batch size 2. Then you have gradient accumulation. I hope I spelled it right. Accumulation steps equals 4. Then you have warm-up steps. Warm-up steps equals 10. Max steps equals 60. Let's keep it a very small just for testing purpose so you can understand how you can use it. Floating point 16. I'm gonna say put a condition not torch dot CUDA dot is, and if BF16 support is not there, supported, that's correct. Okay, now output directory is not fp16, then I have bf16. So it's again torch.cuda is bf16 supported. This is how you should do it. This is better way of defining things. Now logging, because it's not always, it's supported on A100 GPUs. Logging steps equal 1. Let's keep an output directory, and I want to call it Unsloth test, something like this. Okay, it's fine, whatever it suggests. Now let's have an optimizer. I'm going to keep Adam 8-bit. So Adam W underscore 8-bit. And then you just give a seed for reproducibility. So seed for the same seed that we have random state. Let's keep it, make it more. If you want to deploy it, this is the best practice to do that because that's all into a JSON dumps if you are using AWS and kind of a SageMaker kind of a stuff. Now let's do trainer.train. It will take a bit of time, guys. So maybe we will need to pause the video, but let's wait for a few seconds and see what happens here. Alright, so you can see it took around 12 minutes to complete 60 steps, and we got around training loss of 2.72, which is fairly good because you only have done it for 60 steps. It's not even one epoch. If you look at epoch, it's 0.02. I think you have to increase the number, and that depends on what kind of data you have and the compute power you have. Now that's fine. Let's try to inference it. So what I'm going to do here is I'm going to have an input. So let's define an input and keep our tokenizer. So let me write here tokenizer, and then probably, let's create a Python list, and inside list. So we're gonna keep maybe we're gonna keep alpaca format, or probably, so let's try it out. So what I'm gonna do is, or if you don't want to keep alpaca format, how should we do that? Should we only do it like you give your like prompt, or we can just ask a question and we can try to generate that? We can also do that part as well here. So you can support it, supports different types of prompt structure. You can define different prompt structure and you can work along with. So you can also do that. So let's try it out and see eventually what we get here. But now we have fine-tuned. So once you fine-tune, you get a model weights that you can work with it. Now, so let's do that. So here, what I'm going to do is let me first give a question here. So I'm saying, okay, uh, I really like the movie because it shows emotions and talks about humanity. Okay, something like this. Okay, let me have this as an input, and uh, then we can just do a return tensor kind of a thing here. Okay, so let's do that. So here, what I'm gonna do is I'm gonna write uh, return underscore tensors, and of course this is right. Excuse me, and then return tensors, and then you can do dot to CUDA to get it done. Let's see what we get here. Now, if you look at your inputs, let me just get the input thingy over here. You get some tensor value. Okay, over here. Now let's click on output. So what I want to do is outputs. You can also define a prompt format like an alpaca prompt where you have instruction input and then you wait for the output. Like that will be help you with the generation. Now I'm gonna say okay, model.generate. That's what you're gonna do, right? So model.generate, and inside this generate, let's give your inputs and then you give your max new tokens. So our max new tokens is very less because we are working on a classification task over here. So max new tokens, let's give for example 128 or something like that, and then use cache equals to true. Let's keep cache true. So use cache true. Model dot generate inputs max new tokens use cache equal to true. And you can see it took 39 seconds. That's really good. Okay, on this GPU. Now let's print the outputs over here. Once the prints the output, you will get a tensor value. Now let's get tokenizer to decode this. So tokenizer dot decode. So batch decode we're gonna use because it's too many tensor. Okay, so batch decode, and then you just give your outputs. And you can see I really like the movie because it shows emotions and talks humanity and it generates further. You can see it says it's a very good movie and I recommend it to everyone. It is a very good movie and I recommend it to everyone. But now there is a repetitions that you saw here. So that is fine, but it's able to generate the responses that you see. Now what you can also do in this case, you can also keep save the model. Okay, you can save it. This is how you can save it. So you can keep special token equals to true or something like that to see that. Now you can just do model.save pre-trained. So here what you're gonna do pre-trained, and let's call it for example something like LoRa model. It already would have been saved. If you come here in the left hand side, you will have a runtime, and then you'll see Unsloth test, and now you have your runs. It has all the saved thingy in this file, and then if you click on LoRa, you get your adapter config and saved tensors. Now you have your model saved in LoRa. You can also put it on Hugging Face. So if you come here on Hugging Face, you need your API key to push that because you have to write. So if you come here on access tokens, so go on settings, come on access tokens, click on the write, and then you can copy it from here. Then you need to install notebook login and stuff to push that to hub. Okay, so you can push it to hub, get an API key. If I do it right now, it will ask me to put my API key or something because I haven't logged in with Hugging Face Hub. Now if I do that and I say okay, schema 307. This is my name on Hugging Face. If you look at here, Schema 307, and then goes the model name. So I can call it Unsloth, or let's call it LoRa model or stuff. Okay, we can just call it LoRa model, that for the testing purpose. Once you do that, it will ask you to, probably it will give you an error because it's a token is required but no token found. Then you have to install that Hugging Face hub and all of those things over here. So you have to do, pip install Hugging Face hub and stuff to, get it done. It says UTF-8 is required, and something like that. Okay, pip install Hugging Face hub. uh, this is interesting. This gives me an error of, it says get IPython system pip install Hugging Face hub and UTF-8 local is required. Uh, but whatever, right? You can install Hugging Face hub and you can push it to LoRa on the Hugging Face as well. Now you can also merge the adapters. If you want to merge that, you can also do that. You can also convert it to GGUF. You have this notebook on their GitHub repository. You can find it on the GitHub on Unsloth, and how you can merge it. And they have built these classes, merge and unload and stuff, where you can merge the LoRa adapters into the 4-bit model that you have fine-tuned it. But you can see how fast it is once you download the model, and once you use the get-pip model, fast language model, how it do the patching of models with these layers, all the layers, and then how you can fine-tune. So this is what I wanted to cover quickly, guys, in a very short video, that how you can use Unsloth with TRL, train library that we have trained reinforced transformer reinforcement learning, train language model with reinforcement learning. So I hope you've understood now how you can use Unsloth to fine tune it and also inference it with a very fast speed. So this notebook will be available on my GitHub repository, and that concludes our experimentation with Unsloth. That's all for this video, guys, and I hope now you have enough understanding of Unsloth and how you can use this lightweight library for your fine-tuning task. It really helps you speed up your fine-tuning process and also reduces the memory consumption. Supports different type of techniques like SFT trainers, DPO, PPO trainers, and whatnot, and supports models like Mistral and Llamas. Now, the notebook will be available on my GitHub repository. Please find the link in description. And if you have any thoughts, questions, or feedbacks, please let me know in the comment box. If you like the content, please hit the like icon. And if you have not subscribed the channel yet, please do subscribe the channel. Share the video and channel with your friends and to peer. Thank you so much for watching. See you in the next one.